So, question 16 says 6 people are in a room. Each of them has exactly one friend and one enemy in the room. And all friend and enemy relationships are mutual. In other words, if one person is a friend of someone else, then that person is also their friend. Given that a pair of people cannot be friends and enemies, how many different sets of friend-enemy relationships can be formed? Okay, so this makes it a little bit easier for us. There's not some like one-sided beef or one-sided friendship going on. It's if you have 6 people, each of them can be paired up, right? So if this is the friends relationship, all 6 of these are friends. But in another sense, if you pair them up another way, you'll find the enemy pairs. And it has to be paired up a different way for them to be enemy pairs. So I think the way we can do this is find the ways we can make friend pairs, the number of ways we can make friend pairs, find the number of ways that we can make different pairings after that, and then multiply them together. So the friend pairs, to choose this first pair from, let's say you have 6 people, to first choose 2 people to be friends, you get 6 choose 2, and then choosing from the next 4 remaining people, choosing the next pair of friends, you have 4 people choose the next 2, and then finally you have 2 choose 2, which is just 1. So for the remaining 2 have to be friends. And then remember, we have to divide by 3 factorial because even though I chose this group first, I could have chosen them second or third. So the order that I choose the friends do not matter. I could have chosen this exact same pairing, but in a different order, right? So there's 6 different orders that I could have done them in. So that's why I divided by 3 factorial. So I think that ends up giving me, let me know if you want me to write out the equations. I don't mind, but I ended up getting 15 friend pairings. Okay, so if we take a look at this, right? Let's say person 1 here. If we want to give them an enemy, they have 4 choices. Anyone who is not their friend, basically. 4 choices for the enemy. So they would be connected, let's say, like this. And then this second person must, if we were to give them an enemy, would it be these 3 in yellow? No, because if these 2 were paired as enemies, then the final 2 must be paired as enemies, but they are friends. So that cannot be the case. We must get rid of the one that's friends with this person's the one that's enemies with this person's friend. So it must just be the other 2 that is not from the same pair as the first person's enemy. So there's 2 choices. So the first one, there's 4 enemy choices. Then for the next one, there's 2 enemy choices. Okay, and then after those are chosen, the last 2 remaining people must also be enemies. So it's just the first 4, the 4, then times the 2 gives me 8. So that's 8 enemy pairings. Yes, and then just to clarify about choosing, 6 choose 2 is 6 factorial divided by 2 factorial times 4 factorial, where this is just the same as this number. And this 4 is the top number minus the bottom number. And the way I like to do this is a little faster is I see that this number, the bottom number is 2, right? So I just take 6 times 5. I only take the first two numbers from 6 factorial and I divide by 2. Same exactly. And so that ends up giving me 15 friend pairings, 8 enemy pairings, and as I stated earlier, we're just going to multiply those together because all of them, for each of the 15 friend pairings, there's 8 enemy pairings. That ends up giving me 120. Hope that's right. Yeah. 15 times 8 is 120.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.